Hello, this study focuses on converting waste cooking oil into green diesel using nickel-based catalyst. The objective is to develop efficient catalyst supported on activated carbon, reduced graphene oxide, and zeolite. We use a hydrogen-free and solvent-free method which is safer and more eco-friendly.
And I'll continue the presentation with preparation of catalyst. First, the activated carbon and also the reduced graphene oxide. They will undergo the acid pre-treatment and followed by the wet impregnation methods. Then, the nickel-loaded activated carbon and also the nickel-loaded graphene oxide will be prepared. But for the zeolite, it will be used directly without the acid pre-treatments and follow the wet impregnation methods like the previous catalyst. And now the nickel-loaded zeolite will be prepared. So these three catalysts, they will undergo the characterization as shown in this poster.
I will explain about XRD and acidity and basicity part. So basically, XRD was used to identify metal phases and crystallite sites. So nickel oxide activated carbon and nickel oxide reduced graphene oxide show both nickel oxide and metallic nickel thanks to carbon acting as a reducing agent. This lead to a smaller crystallite size and better metal dispersion. In contrast, nickel oxide zeolite only show nickel oxide with larger crystallite size and poorer dispersion. So for acidity and basicity part, nickel oxide activated carbon has the highest acidity and basicity, which nickel oxide reduced graphene oxide had moderate acidity and basicity, while nickel oxide zeolite had the lowest, making it the least effective. So overall, nickel oxide activated carbon is the best catalyst due to its strong acid-base properties and high metal dispersion.
Through back analysis, nickel AC exhibited the highest surface area and pore volume, making it a highly efficient catalyst. Nickel Geo show moderate surface area, while nickel RGO had the lowest, like due to sheet stacking. Next, we go to the FSAM and ADX surface analysis, which revealed the important structural findings. Nickel AC demonstrated a rough surface with small nickel aggregates, ensuring good dispersion, while nickel RGO had crumple sheet with evenly distributed nickel particles, while nickel Geo showed larger nickel particles agglomerates on spherical zeolite.
Next, I will continue with liquid selectivity. So this statement shows the catalytic oxidation of WCO reactions condition. And then we proceed with the first figure, which shows that blank without catalyst show lowest yield, which is 12%, while catalyzed reaction produce yield significantly within the range of 78 to 89%. And the next figure shows that activated carbon catalyst yield the highest hydrocarbon, which is 89%, and it says that high acid-base site distributions enhance hydrocarbon productions. It can be assumed that the amount of acid base plays a critical role in controlling reaction pathway.
First, on optimizations of nickel 20 on activated carbon catalyst. Nickel 20 on activated carbon means 20% nickel supported on activated carbon. The best result were achieved using 5% catalyst loading, 3 hours reaction time, and 350 degrees Celsius. This gives 90% hydrocarbon yield and 89% selectivity towards C15 and C17. Higher loading or temperature reduced performance due to cracking. The catalyst stayed effective over 4 cycles, maintaining 85 to 87% yield. Slight deactivation occurred due to coke buildup and nickel carbide formation. Activated carbon support helped reduce coke thanks to its mesopore structure. For elevator results, nickel can be combined with metals like lanthanum, copper, or iron.
For the application of catalyst, nickel-based catalysts were used to convert waste cooking oil into renewable diesel fuel. This was done without any solvent or hydrogen, making the process cleaner and more sustainable. Among all tested catalysts, nickel 20 activated carbon performed the best. It achieved 90% hydrocarbon yield and 89% selectivity for diesel range hydrocarbons. Nickel 20 activated carbon also showed great reusability, staying effective for 4 cycles. Plus, it reduced side reactions and minimized coke formation. Nickel 20 activated carbon makes renewable diesel production more efficient and environmental friendly.